Alright, so our question is, what is the osmotic pressure of a solution containing 7.10 grams NaCl in 100 milliliters of water at 25 degrees Celsius? Okay, so we see osmotic pressure. That means we're going to be using our osmotic pressure equation, which is I equals mRT. IMERT. Okay, so our first step is going to be to figure out all of the parts of the equation that we need. So we already know what R is. It's a constant. It's going to be 0.0821 liters times atmospheres over K times moles. Alrighty, so we have that part. Next, go on to the easy part. So we know that our temperature is going to have to be in Kelvin. So we have 25 degrees Celsius. That's a real simple calculation. We're just going to do 25 degrees Celsius, and we know to change it to Kelvin, the difference in freezing point is 273 degrees. So we add that on. That's going to give us 298 degrees. So we have 298 degrees Kelvin. Now all we need is our I and our molarity. So we'll do our I first. I is also known as the Van't Hoff factor, and so that's just how many ions our molecule is going to break into when it's in a solution. So we have our NaCl. This guy is going to break into a positive sodium ion and a negative chlorine ion when it's put in a solution. So that means our Van't Hoff factor is going to be 2, because we have 1 ion plus 1 ion, that gives us 2. So Van't Hoff factor is 2 in this case. And lastly, we have to figure out our molarity. So we're given 710 grams of NaCl. So we have 710 grams sodium chloride, and in 1 mole of sodium chloride we have 58.44 grams. Alright, quick punch in the calculator is going to give us 0.1215 moles of NaCl. And now to figure out our molarity, we just have to divide by the amount of solution, and in this case we have 100 milliliters, and this is going to have to be in liters. So 100 milliliters is 1,000 milliliters in a liter. That's going to give us 0.1 liter. So we have 0.1 liters. That is going to give us 1.215 molarity. Alright, just bring this boy over here. 1.215 molarity. Okay, so now that we have all the pieces of our equation, I'm just gonna free up some space to do our calculations. Alright, so now take our equation and we just plug everything in. So we need the osmotic pressure. Our I is 2, the Van't Hoff factor. Our molarity is 1.215. Our R is our constant. It's going to be 0.0821 liters atmosphere over K times moles. And lastly, our temperature, which is 298 degrees Kelvin. So just plug these guys in the calculator, and that's going to give us 59.45 atmospheres. And there you have it.